Hi, welcome to this video lecture series on simple circuits, and let's just go ahead and jump right back in. So now what I'd like to do is talk about if we have multiple loads on the same path, right? A single power source, a single open or close, a single pole, single throw switch, but then can control multiple loads at the same time, and how those loads use different kinds of electricity, or the different parts of electricity, right? So this is a series circuit, and if you'll look at our path, you'll see that our path flows out of our battery, through our switch, through the first light bulb, down through our second light bulb, and then back to our battery. This is a series circuit. All of the loads are in series, connected end to end to end. If one of these light bulbs were to burn out, then the entire circuit would be open and none of the light bulbs would work, because that filament burning out and breaking means that electricity can no longer flow through it. This is the way that Christmas tree lights used to be wired. LEDs not as much anymore. But if one of the light bulbs were to go out, all of the light bulbs go out. And it makes me crazy. Christmas tree lights make me crazy. So the way that this circuit uses electricity is each of the light sources split the voltage available, right? They share the voltage available. So this has a 6-volt battery, and the electrons are coming out and they're kind of excited, and half of that excitement is used with the first light bulb and half of it is used at the second light bulb. The net result is that these lights glow half as bright as they would if there were only one light bulb. Now, if we were to add a third light bulb here, then each light would use 2 volts from our available 6, because there would be 3 lights and they would use 2 volts each for a total of 6, and they would be even more dim than with just the 2. So that is a series circuit. Next, I want to talk about a parallel circuit. A parallel circuit is more like a stage light, or almost any other kind of light that might be tied together other than a Christmas tree light. And what happens in a parallel circuit is that we sort of have each lamp has its own pathway that connects it to the positive and the negative side of the battery. And you can see in this example, if we close this switch, our electrons flow out, and then electrons go down this first path across the first bulb and continue down across the second bulb, and then all of them rejoin and come back to the end. This is a parallel circuit. If one lamp goes out, the other circuit is still intact, and that light bulb will continue to work, right? In this example, the lamps split the amperage. They split the number of available electrons. Actually, what they're going to do is they're going to draw twice as many electrons. This will drain this battery twice as fast as if we had only one. It's drawing, both lamps are drawing as their full power from this battery. So the battery is going to drain twice as fast. However, both lamps are going to illuminate at their full capacity at 6 volts. Both are equally excited. We're just asking more electrons to flow through this piece of wire to illuminate these. Let's go down and let's see something else. What happens if we put power sources in series? If we were to put a battery end to end, and I will venture in many instances, what you do in your TV remote, you have to put the batteries in one direction and one the other direction, or in a flashlight you may install them end to end. And what you're creating is a series circuit with batteries. What happens when we do that is we actually add the voltages of the batteries together. It's important to note that the battery should be the same voltage. You don't necessarily want to mix a 6-volt battery and a 1.5-volt battery, even though mathematically it would work. But you want the batteries to be of the same voltage, and you would put the plus side of one battery to the negative side of the other battery. And what you get, you've just made essentially a bigger battery. And what happens is you add the voltages together. So now this circuit is passing 3 volts to our light and then returning it back to the first battery. That is series for power sources. This is parallel for power sources. If I take 2 6-volt batteries and I connect their 2 positive ends together, and I take and connect their 2 negative ends together and send that power out through a switch, through a light bulb, and then back to the batteries, I still only have 6 volts, but I have twice the number of electrons available. I have twice the amperage. And I can give you a fairly common example of this is in tractor trailers, in big trucks. Big trucks will often have multiple batteries because the engine is so large, they need so much power to be able to make that engine turn over so that it can start, and they will connect their batteries in parallel so that they have more electrons available to send to that starter. They can get more work done. They don't necessarily need more excitement, right? They don't need a higher voltage, but they do want higher current, greater amperage. In this particular instance, these 2 batteries will stay charged, will drain, will last twice as long as either one battery would do by itself. So this is parallel circuits for a battery source, and I will tell you that both parallel and series power sources only apply to batteries. Oh, and in this instance, the voltages must match. 6-volt and a 6-volt. The voltages must match. They could be of different current capacities, but that's not ideal. Ideally, you want batteries to match whenever you're connecting them together to change a power source. That concludes simple circuits. I hope you had fun and that maybe you learned something. Thanks so much.